There are so many ways we can sense the world around us. Most of the time, we use our eyes, ears, even our sense of smell to gather information. But what happens when the information we need is too far away to sense directly? It turns out that engineers have developed remote sensing technologies that can help us learn about things that would otherwise be far beyond our reach. To learn more about remote sensing technologies, I traveled to NASA's Jet Propulsion Laboratory, or JPL, in Pasadena, California, where scientists and engineers focus their research on the robotic exploration of the solar system. I met up with Tracy Drain and Ingrid Daubar to see how they collect information about other planets that are millions of miles away from the Earth.
I'm Ingrid Daubar. I'm a scientist here at JPL, and I study all the data that we can possibly get about all the planets in our solar system, trying to understand where the planets came from and ultimately where we all came from.
I'm Tracy Drain. I'm a flight systems engineer here at the lab, and my job is to work on spacecraft and instruments and help scientists like Ingrid get their instruments where they need to go to get all the data back so they can learn about our solar system.
I've heard that you use something called remote sensing technologies to learn more about the solar system. What is remote sensing?
Ideally, we'd be able to send people to every planet in the solar system, but that's really hard to do. It takes a lot of time and money, and it's not very safe right now. So instead, we try to gather as much data as we can remotely, which means at a distance. So we try to figure out what things are made of and what shape they are without being able to touch them.
Are remote sensing technologies used here on Earth?
Yeah, a good example is if you've ever had like an X-ray or a CAT scan at a doctor's office, that's a way that they can figure out what's inside your body without actually cutting you open.
Another example is, say you're going into a grocery store and you get close to the door and magically they open. But that's because they have a sensor that can sense that someone's walking by, and so it opens the doors for you.
Can you tell me a little bit about a mission that's using remote sensing technologies to learn more about Mars?
Let's talk about the Mars Reconnaissance Orbiter, or MRO. This is a spacecraft that was launched in 2005, and it's been orbiting and studying the red planet since 2006.
One of the instruments on MRO is HiRISE, which is a high-resolution camera. It's a really special camera. It images Mars in very high resolution, which means really close-up pictures of very small areas on Mars. So it takes images of geologic features that are just, a few meters across. So if there was a car on the surface of Mars, there isn't, but if there was, we would be able to take pictures of it.
There is kind of a car, but not really. There's the Mars exploration rovers, which are there. I actually have a picture on my living room wall that has the big, beautiful Victoria crater, and you could see that there's one of the MER rovers sitting next to it. It's kind of fuzzy, but you could tell that's what it is. You could even see the shadow from its camera mast and the tracks leading up to the crater and how it was exploring the edge.
So how does the HiRISE camera work?
So sunlight bounces off the surface of Mars and into the HiRISE camera, and then the light really bounces around inside of HiRISE between a bunch of different mirrors, and then finally it hits sensors, special sensors in the back of the camera that are a lot like the sensors in your digital camera.
And then that data gets transferred over to the spacecraft, which transmits it all the way back to Earth.
Tracy and Ingrid told me that engineers often combine remote sensing technologies with other technologies, so they can use multiple tools to get different types of information.
The spacecraft before Mars Reconnaissance Orbiter had a remote sensing technology called LiDAR, light detection and ranging. That allows you to generate kind of a 3D image of the surface. You can see where the mountains and valleys are, which lets us create a whole topographical map.
So how does LiDAR work?
So a LiDAR will send a pulse of a laser down to the ground, which will bounce and then come back. And it travels at the speed of light. And since we know how fast light travels, we can measure that, and the time it takes will let us calculate how far it is between the instrument and the ground. And then you do that multiple places around the planet, and you can put those together into a map that gives you the shape of the surface below you.
So it's kind of like those pin screens where each of the laser pulses is one little pin, and it tells you whether you're on a mountain or in a valley, and that tells us a lot about the geology of Mars. So we take all of these thousands and thousands of LiDAR pings and we map them out over the whole surface of Mars to get a topographic map of the whole globe.
Oh, why don't we take a look at this?
Yeah, so this is a whole map of Mars using the LiDAR remote sensing technology. And what it shows us is the high areas and the low areas on Mars.